So you're line following and you have various shapes in the line that you can detect. And you want to be able to detect those lines so that you can make decisions, make turns, make stops, and things like that. I recently got a request from a viewer for an algorithm that can follow a line but also can count and then stop at the end of a track. Now, I'm just going by my assumptions here that the end of the track is going to be a T shape or something like that, where you have a line of tape that's perpendicular to the path of the robot. So what I've done is I've taken my track that I had that's a typical oval shaped track, and I have added a cross piece so that I can count that. I'll also be treating that as the end of the track. So there are a couple ways to do this, and normally, okay, so I'm going to use my 3Pi robot, which has an odd shape to the array of sensors. It has kind of a curvature to the sensor array. So normally with a straight sensor array like the QTR8A or the newer sensors, they're all in a straight row. So I could typically say, are all of these sensors seeing black? If they are, then I know that I'm at a perpendicular line. Since the robot has a curvature to these sensors, I'm going to say, are just the outside two seeing the line? So this way, the leftmost sensor and the rightmost sensor, if they see the line, then I'm pretty positive I see a perpendicular line. So I came up with three possible solutions to this. There are many, many more, but these are the three that I thought would not only be the ones that people would most likely go to, but also the simplest ones to solve the problem while still being somewhat robust in their solution. So I'm going to start with, just so you can see this code here, this is just a basic line follow code. I'm using the 3Pi robot, so there's a lot of libraries included here. Don't worry about that. Just, if you have a line follow algorithm, you can just go based off of this. I just have my one command to follow a line in here. Okay, and that's just taking all of the PID calculations, which if you don't know about these, you can check out one of my other videos on how to program and tune a PID line following algorithm. But basically you just shove that into its own little function called follow line, and then you call follow line every time the loop iterates. So what I'm going to do is I'm going to add a function here, and I'm going to call it, we'll call detect intersection. It's not necessarily going to be an intersection, but we'll just name it that. I don't want to say detect line because that's kind of ambiguous. You don't really know what the line is. So we will create that here. Okay, so what do we want to do here? Like I said, you want to check the outermost sensors to see if they are seeing a black line. What you might not know is that this readline function that you use in the QTR sensor library actually accepts the parameter sensor values, and then what happens is inside of the readline function, when it takes the readings from the sensors, it's feeding back and storing those values that it took from the readings and storing them in sensor values. So if you look at where you created sensor values, it's a 5-element array, and I have 5 sensors. So basically, anytime I call this function, readline, it's going to populate this array with the 5 sensor values that it got while it took the reading. So I can use those individual values and determine if it's seeing a black line. So check outermost sensors for black reflectance. Okay, so if sensor values, and arrays always start with 0, so the first or the leftmost sensor is going to be 0. If that value is greater than or equal to some, we'll call it black threshold, and I haven't defined this yet, so I'll talk about that in a second. But I also want to check the rightmost sensor, and since we have 5 elements, the rightmost sensor is going to be the 4th index in this array. Because we have 5 and it's starting at 0, so it's 0, 1, 2, 3, and 4. So that one might throw you off a little bit. Just keep in mind when you deal with arrays that they start at 0, so everything is 1 less than the actual size of the array when you're referring to the indexes. So that's also going to be black threshold. So if sensor value 0, which is the first leftmost sensor, and sensor values 4, the rightmost sensor, are greater than or equal to black threshold. Okay, so let's go, before we forget, define what black threshold is. Define black threshold, and you could use a constant if you wanted. So what I'm going to do is basically, I know that when I'm seeing white, I see almost a near zero value coming back. And my timeout is what defines my maximum value. So when I'm seeing black, I see close to 2000. When I'm seeing white, I see close to zero. So I'm just going to, just as a simple go-to value, I'm going to say it's going to be whatever timeout is divided by 2. So that way, whatever my maximum value is, it will be anything above 50% will be considered a black reflectance. Okay, and then what I want is another variable. Let's call this, let's see, we could use unsigned char line count, and we'll start at 0. Always initialize your variables. Okay, so if we see this, we want to increment line count. So line count plus plus, we could also use plus equals 1, or we could use line count equals line count plus 1. This is great. It's going to follow the line, and then it's immediately going to check for an intersection, and then it's going to follow the line, check for an intersection. The problem here is that the loop has so little to do in here that there's a possibility, well, almost a certainty right now, that it's going to go through this loop so quickly that it's going to detect that intersection more than once for the same intersection. So this is where I came up with 3 different solutions to this problem. The first solution, the simplest, and probably the one that people are going to default to the most if they're beginning programming, is using a delay, which is my least favorite solution, but I just want to walk through from the worst to the best the solutions that I came up with. So the idea is that as soon as you see a black line, you're going to delay and give your robot time to extend beyond the line before it starts checking again. So drive forward a bit. So what we'll do here is we'll set our motors to the set speed, which is just a variable that I have, or a defined macro that I have, which has my goal speed for the robot. And we want both of them to go the same speed. So basically what this is going to do is say, as soon as I see the line, turn on my motors to the same speed so I go straight, and wait for, I don't know, let's say 250, so a quarter of a second, 250 milliseconds. So we're done with our detect intersection, and now we need to say what we want to do when the line count is right now it's just counting lines. So what we want to do is we want to say if the line count is greater than or equal to 2, then turn the motors off. And we will just have a while loop here that doesn't have anything in it, so it just loops on forever. So basically, once we see 2 lines, it will turn off the motors and then just sit here forever until we reset the robot. Let's upload this. Let's verify. Oh, we got a mistake here. What did I do? Oh, you know what? I have a habit of adding semicolons to my define statements. And they should not have a semicolon, so it was getting confused there because it was adding a semicolon here and here before I had finished my if statement. So that's done compiling. Let's upload this and let's see what it does. All right, so from the video, it looks like it worked pretty good. You will notice when we go into the next algorithms that it went a little bit farther than it should have when it saw the intersection, because we have that quarter-second delay. Now you could drop that delay down to a smaller delay, but then you kind of risk getting too close to the sensor, and based on your speed, you might not go beyond the tape before you go to check again, and you'll detect that same intersection twice. So now let's change this, and let's modify it to my second solution, which is a good solution, although it's not the most optimal solution. So it's much better than using a delay. But what we're going to do is instead, we're going to basically we're going to add a variable, and we're going to keep track of when the last time we checked for that line was. So let's do this. Static long. Make sure we use long when we're recording time, because time can be a very big number. And long will give us up to 2 billion. And then if we unsigned long, it'd be 4 billion. But let's do last detected. So this will be the last time that the line was detected. Okay? And then what we want to do is say if the current time, so the current millisecond time, minus the last detected time is greater than or equal to some, oh, actually, no, we want to do less than. So if it's less than some amount of time, we want to just skip back and not do this function. So let's say we know it takes about a quarter of a second to detect the line. So we will say if it's less than 250 milliseconds, then we just return. So just to clarify this statement here, a static variable is a variable that's created inside of a function, so it only has visibility inside of this function as far as scope. However, it's not reset every time that the function is created. It still retains its memory. So what we're doing here is saying if the current time minus the last detected, so if the current time is 100 milliseconds and the last detected is 0, then we'll have 100. If it's less than 250, so it hasn't been a quarter of a second since we saw the line last time, we're just going to return. Okay, and then this code will pretty much be the same. However, we won't need this delay, and we won't need this because we're not going to drive forward for a bit. We're just going to do it this way. So we're going to line count, but now we need to reset the time that we last detected it. So here we've detected it, and we need to say update last detection time. So that's last detected. And we'll just, for this, we'll just use millis. Okay, so that's going to reset it. So the next time we come through, if we detect the line, it's going to reset the time to the current time that we saw the line. It's going to increment the line count, and then that way it won't check again for another 250 seconds. It'll come in here. It'll do, let's go looking at our loop here. It's going to follow a line, which is going to perform the line following PID algorithm. Then it's going to detect intersection, but for the next quarter second after it detects an intersection, it's just going to come right back out of this without actually checking for an intersection because of this section that we have here. Okay, so let's check that. Make sure I didn't make any goofs. All right, we're good. Let's upload this and see how it goes. So that one looked much better. It stopped almost immediately on the line because this time when it saw the line, it didn't wait. As soon as it saw the line the second time, it just went right back out and went to motor stop. Okay, so this one's nice. However, if you have a lot of lines that are in a row with a short distance between them, this could get a little tricky. Also, again, you're dealing with time, so there is the possibility that you would not have a long enough delay, and then you would detect the same intersection twice. So it's better than a delay, but it's not the best solution because it still relies on time, and you're just guessing when it comes to time because your motors are not going to always be the same speed, and you're going to have a lot of other variables in. So let's move on to the final solution that I came up with, which is my favorite solution for this sort of algorithm, and that is that we will detect the line, and the same way we're detecting line, we'll just loop until we don't detect the line anymore. So we don't need these because we're not keeping track of time. So let's get rid of this. Okay, so we are checking for the black line, and then we're increasing the line count. But what we want to do is we want to not leave this function until we've finished seeing the black line. So we'll start to see the black line. We'll keep going until we no longer see that black line. So what we're going to do here is simply change this if statement to a while statement. So while we are seeing a black reflectance on the leftmost and the rightmost sensor, we don't really want to do anything. However, because we have this while loop, we're able to follow the line. Now, since we're over an intersection, follow line technically isn't really going to work all that well because all sensors are going to be seeing a black reflectance, but that should give us a center weighted response. So it should still follow on the center when it's following over the line. But what this is also doing is follow line, because it has robot.readline. This is updating our sensor values so that we can get new sensor values each time this while statement is checked. If we didn't have this in here, then these sensor values would never change, and we would just keep looping on forever. Likewise, we could not follow the line and just call robot.readline and put that in here. And then that way it would just keep doing what it's doing, but we don't know what the motors are going to be doing at that point, so I'd rather have control over it by telling it to follow the line. So let's try that out. So that one looks identical to the previous solution. However, this algorithm will always work no matter how thick the line is, no matter how slow your robot's going, no matter how fast your robot's going. So this one, out of the 3 solutions that I came up with, is the best solution that you could go with, because it does not rely on time in any way, shape, or form. If you can think of any other solutions that I should have included here, or you think of a solution that might be better than one that I came up with, feel free to leave a comment down below, and I can include that in the next video that I do on line detection and intersection detection and different things like that. Hey everyone, thanks for watching. If you like this video and you want to see more like it, give me a thumbs up. And don't forget to subscribe.